Building on our previous talk about the data splitting strategy, where we divided our data into training and testing sets, let us look at what happens next. Hello AI enthusiasts. Welcome to a new deep dive. Most videos on machine learning treat hyperparameters as magic numbers that just work. In this video, we want to show something different. The architectural blueprints that define how your model learns before a single piece of data is even processed. Think of it like baking a cake. Before you ever touch the flour or eggs, you must decide on the oven temperature and the bake time. These are your hyperparameters, the external settings that dictate the environment where learning happens. In technical terms, hyperparameters are configuration variables that are set before the training process begins. Unlike the internal weights of a model, which are learned from the data, hyperparameters are fixed by the designer. Imagine a control panel on our oven. We can slide the temperature dial to exactly 350 degrees. We do not wait for the cake to tell us the temperature, we set it ourselves to ensure the best results. If the data is our ingredient list, the hyperparameters are the rules of the kitchen. They are not learned, they are chosen. The most famous hyperparameter is the learning rate. This dictates how large a step our model takes as it tries to minimize its errors. Think of this as the speed of your electric mixer. If you set the speed too high, you will splash batter all over the kitchen walls. This is like a high learning rate that overshoots the best solution. But if you set it too low, you will be mixing for hours without ever reaching a smooth consistency. Finding that middle ground is essential for the model to converge efficiently toward the perfect result. Next, we have the batch size, which determines how many data points the model looks at before updating its internal knowledge. In our kitchen, this is like deciding how to add your dry ingredients. Do you add the flour one tiny spoonful at a time? Adding it spoonful by spoonful is very precise but takes forever. Dumping the whole bag is fast, but it might create lumps that are hard to smooth out. A medium batch size often provides the best balance between training speed and the stability of the learning process. The number of epochs is another vital hyperparameter, representing how many times the model will see the entire dataset. Think of this as the timer on your oven. If you pull the cake out too early, the center will be raw and unformed. This is what we call underfitting. However, if you leave it in for too long, the edges will burn. This is similar to overfitting, where the model learns the noise of the data instead of the patterns. We set the number of epochs to ensure the model is cooked just right, fully developed, but not overdone. Finally, we consider structural hyperparameters, like the number of layers and neurons in a network. These define the capacity of the model. In our baking analogy, this is the shape and size of the cake tin. A small cupcake tin can only hold a little batter and create simple shapes. A massive, multi-tiered wedding cake mold allows for incredible detail and complexity. By choosing the architecture, we are choosing the container that will hold all the knowledge our model acquires. Hyperparameters are the essential settings that define the journey of machine learning. They are the temperature, the speed, the time, and the shape that we decide upon before the first data point ever enters the system. While the model learns its own weights, it relies on us to provide the perfect environment. Understanding these variables is the first step toward building models that are robust, efficient, and accurate. By mastering these external controls, you set the stage for your artificial intelligence to truly succeed in its learning process. Subscribe for more deep dives into hyperparameters.